Hello and welcome to the 14th part of the tutorial on writing your own operating system. In the last video we didn't finish the GUI framework, so we didn't implement the desktop and the window class. We will do this now. And a funny thing, in the last video, at the end of the last video, I compiled the code and it compiled fine, so I was happy. And then later I realized, wait a minute, why did it compile? I didn't implement the contains coordinate method for the widget class, so it shouldn't have compiled. And then I realized, okay, here in the make file, I didn't put the objects for the desktop widget and window class there. So that's the reason why these codes weren't even compiled into the binary. Not much to talk about beforehand. Everything has been discussed already in the last video, so we can just jump right back in, okay? Okay, so I will put these object files also here. Okay. Now when we compile, we will get less good results. So here we get errors now. Specifically, we didn't write the contains coordinate method, so I will do that. But the first thing, the first error it reports is this here in the common graphics context. This is the wrong way around. Okay, and now let's implement the contains coordinate method. We'll do this in a quite simple way. We'll just check if this x and y are larger than the x and y coordinates of the widget and smaller than the coordinates plus width or height respectively. So Okay. Yeah, it's important to notice, this x and this y, they are relative coordinates, but this still works because down here in the composite widget, here we turn the coordinates that we get into relative coordinates also. Okay. So the things that we pass down here are also relative coordinates. Okay. One thing I thought about, this code here is a bit ugly because, yeah, we only call onMouseMove either once or twice, depending, depending on whether the first and the second one are the same. I think a more elegant way would be to check if they are the same, and if they are the same, you call onMouseMove, and otherwise you call something like onMouseLeave on the first widget and onMouseEnter on the second widget. So, yeah, I mean that's common practice in GUI frameworks, but I'm gonna leave it like this. You can figure that out for yourself if you want to. Okay, one thing that I have noticed is in the mouse driver. Here, when we send this onMouseMove, it kind of baffles me because with the mouse cursor in the text mode, this worked. But when I went through the code beforehand, I noticed that this doesn't work, strangely, for the desktop. So I will just cast this to int before passing these to the event handler. Okay. Now the next thing, I think it would be a good idea if we would derive the widget class from keyboard event handler, so that we don't have to write these onKey down and onKey up explicitly. We can just inherit them from keyboard driver, and then we can just attach a widget directly to the keyboard. Okay, and we will actually attach the desktop directly to the keyboard. So we can just remove this. And then we have to include the header, of course. Like this. Let's see. Okay, so the keyboard event handler onKey down and onKey up just get a character. So down here, X and Y was nonsense anyway, so Okay, and I also want to derive composite widgets from mouse event handlers. Actually, no, I'm not going to derive composite widget from that. I'm going to derive the desktop from it. Okay. The mouse down here and mouse up, I will give them an additional parameter. They will get also, the button that has been pressed. So. Wait, I haven't declared the method contains coordinate. Okay, then we can remove these methods because we inherit them from the keyboard event handler. But the one down here, for the composite widget, we override them so that a composite widget like the desktop can pass the key strike to the focused child. Okay. Okay, and the composite widget also needs something like a method to add a child, because the children are private and you shouldn't access it from outside anyways. So. I'll make that bool instead. So if we already have as many children as we can, then we will just return false. What was the limit? 100. Okay, so this isn't exactly thread safe, but whatever. Right now everything is synchronous still anyways. Okay. Okay, now let's see if this compiles. Draw method, yeah. The graphics context is in the namespace common, so that makes sense. Ah. Okay, the on mouse down and on mouse up. I gave them this additional button parameter. Of course, I also have to do that in the CPP file. And in the derived class. Yes, you need to call the base constructor. Okay, now it compiles again. Okay, before I continue, I will add a few more colors to the VGA driver. And also these commas were wrong. So color 1 is blue. Color 0 is black. Color 2 is green. 4 is red. And color 3F is white. Okay, so now let's start writing the desktop and window classes. So the desktop, of course, is a composite widget because it has windows on it. And the desktop will also be derived from mouse event handler. Okay, so the desktop will basically just work like the composite widget. So we don't actually have to do much here, but we will have to override the methods from the mouse event handler to translate the mouse movements, because from the mouse we only get relative movements, and so the desktop will turn these relative movements into absolute positions of the mouse. Okay, so so the desktop will get mouse coordinates, although I have read that it's apparently not a good idea to hard-code a mouse into the desktop, for example, because of tablets. You know, the tablet doesn't have a mouse cursor. So, but anyways, I will do this way now. So for the desktop, we only need the width. The height. Actually, width and height could also be unsigned integers, but whatever. And it will also get a color. So the desktop will be responsible for drawing the mouse, so we have to override the drawing of the desktop. And as I've said, the events for the mouse event handler. Okay. Okay, so the desktop constructor will go to the base constructor. Like this. So I'm assuming here that there's only a top-level desktop. Okay, so so it will not have a parent. So this is 0. It will have x and y coordinates 0 because it's supposed to start in the upper left corner. I mean, yeah, you could do this actually. You could do it so that you can pass other parameters here, because I think using a desktop as a child for maybe a window, for example, would be probably a good idea if you wanted to do something like a multi-document interface, the MDI form parent that you possibly know from Windows. Where you can have a window which has child windows in them. Okay, so then it would make sense to have a desktop which has a parent and something else than 0 for x and y coordinates. But I will do it like this here. And I will initialize x with, with just the width of the screen divided by 2, so that it's centered. Okay, so the initial mouse position is the center of the screen. Okay, the on mouse down and on mouse move and on mouse up are also relatively simple. So mouse down and mouse up basically just call the event handler for the other. So I mean, this is a mouse event handler on mouse down, right? It just has a button as parameter. This is what the mouse calls. So if the mouse does something, this is called, and this translates it to the widget form where you get the mouse position and the button. But this is really simple. We just have to pass the current mouse position, mouse X and mouse Y, together with the button to the other handler. So this is all we have to do for mouse down. For mouse up. Then the mouse move is a bit more complicated. Because we need to make sure that the mouse stays inside the screen. So, but that's not hard. Okay, and then we call the event handler, the widget event handler. And then we store the new values back in the coordinates. And here at the beginning, I will just divide the relative movement by 4 because it's relatively fast. Okay. So how do we draw the desktop now? Well, most of what we need is already implemented in the composite widget. So we'll just call the parents vo draw now. And after this is drawn, so after the screen has been drawn, we put the mouse cursor in. And I will make the mouse cursor a little white cross, okay? Okay, but now we have a little problem. I'll just show you the problem. So So now I've instantiated the desktop. I think that's kind of funny, don't you think? It's talking about I instantiate the desktop. But okay, that's what I'm doing here. So another strange way of saying something is if you comment this out. I think it's also a bit hilarious to say I've commented out the desktop. It's something that I've said someday, and I was really I found that quite funny. Okay, yes, I'm a nerd. So let's see if this compiles. Okay, wait. Right now, okay, we have the desktop now. You see, we have a mouse cursor. Right now, it doesn't react to the mouse because, we haven't attached the desktop to the mouse yet. So I will just instantiate the desktop up here. Okay, now I have attached the mouse to the desktop, and while we're at it, we can also attach the keyboard to the desktop. Okay, let's see. This should compile. Yes. Okay, so now the mouse is connected to the desktop, but if I move the mouse, the cursor still doesn't move. The reason for this is we just draw the desktop once down here, and we don't update it. So I will just put this into this loop here. Although I warn you, when we go to the multi-threading, multitasking, when we start the multitasking, this loop will never be executed anymore once we start tasks. So this isn't a really good idea to put it here, but for now it will work. And also we should activate the interrupts. Really, activating the interrupts should really be the last thing we do. And that's also why we shouldn't do it like this, because this is after we activated the interrupts. So it's really not a good idea to redraw the desktop inside this loop, but we'll keep it like this for now. Okay, now you see the screen is flickering a bit. I think that's okay. And now I can move the mouse. And the mouse is now really gone. So it's if you look closely, I don't know if you can see it in the video, but it's flickering up here. Whatever. So a problem that we have is that we are calling the putPixel method for the VGA, and the putPixel is really, it doesn't care whether the coordinates are legal right now. And so far we have only passed legal coordinates, but when we move the mouse, we cannot be sure that the coordinates where you move them are legal. For example, if this is the screen and you move the mouse here to the right of the screen, then we try to draw the cross, and it goes beyond the screen, and that's not really what we want, because then these pixels will just be drawn in the next line. So we will just put some security here. Okay, these are unsigned integers, so x smaller than 0 is impossible. Why are they unsigned, actually? I mean, it might be a bad idea, so this could potentially be cause problems when we cast unsigned to when we cast signed integers to unsigned. Okay, now this makes sure the coordinates are legal. Okay, I still get this strange error that I've talked about. Okay, so what have I done? I casted this to int 8t now, so yeah, strange behavior, whatever. So you see the screen is flickering a bit, but now I can move the mouse. And this is already something I find quite cool. So let's do the window class now. Okay, so I'm not going to do a lot with the window. I will just make it able to be dragged around the screen, okay? And I will do this in a quite simple way. I will just override the on mouse down and on mouse up to set a flag which tells us if the window is currently dragged. And if it is set, then in the on-mouse move, I will just change the x and y coordinates of the window. Okay, so yeah, initially, oh wait, we need to call the base constructor. So initially we will set this flag to false. When the mouse is released, it will also be set to false. The on mouse down will set it to true, but only if we are clicking with the left mouse button. So dragging is set to button equals 1. And in the on mouse move, I will look if it is being dragged. Then we will just change the x and y coordinates. Come to think of it, we should call the base methods for this, of course, because otherwise the widgets that the windows contained would never be notified. If they are being called. Okay, this x, if we move it to the right, then the new coordinate minus the old coordinate is positive, and then we add that, so okay, this is all, I think. So let's go to the kernel. Now let's make two windows. Attach them to the desktop. Let's say add coordinate 1010 and with width and height 20. And let's give it color red. And a second window. And let's put that right next to the other one, but maybe a little bit down. So this is going to 30, so let's have 40 and 15. And let's make it a bit bigger, like this, but this one I'll make green. Okay, and the desktop needs to be notified. Okay, I don't know how good you can see this. So the screen is flickering a lot here. But I'll just move the mouse over here. It's a bit unresponsive. Okay, I will click now and move it down here. Ah, yes, you can see I can move the window now. Okay. Okay, so yeah, this is really all I wanted to do for the graphics mode. I think this is quite nice now. We have a desktop. We can have windows and composite objects. I mean, I think you can imagine now how to create further widgets like buttons and text boxes and radio buttons and checkboxes and all these. So I don't want to go any further into this topic. I think it really sucks that the screen flickers so much. I mean, these drawing methods are relatively slow. I mean, every pixel is set for its own. I think graphics cards should have methods to tell the graphics card to draw a rectangle on its own. So then you would just need to override the fill rectangle with something that calls this method of the graphics card. So then this rendering would not be so slow anymore. But on the right side of this class hierarchy here, everything can stay the same. You know, this is really great, I think, because widgets, composite widgets, desktop, window, they were all written in a very abstract way. So you can have a better graphics card driver if you want to. And so a better graphics card driver will give you better resolutions maybe and better performance when you draw. But everything here, everything in the GUI directory can stay the same. So if you want better graphics, better resolutions, faster graphics, you just have to change the driver for the graphics card. But I'm not going into that. And everything here can stay the same. And that's really nice, I think. So, what else? It might be a good idea to have methods which notify objects, widgets, when they are focused or unfocused. One other thing, I mean, this whole idea, the way we did this is actually quite bad, I think. This whole redrawing the screen all the time, it's really not a good idea, I think. A better idea would be to draw the screen once and don't redraw it at all. So every widget draws itself, so it is there for the time being. But a program or any graphical object should have a method which says invalidate this area of the screen. Okay, so here's the screen. You draw it with the windows, and you don't redraw it all the time. You just leave it like this, and only when something happens, like you move a mouse, and maybe you have moved the window now over here, so it's now should be like this. Then you could just memcopy these pixels over here and invalidate these two areas of the screen. And invalidation would mean that you put rectangle objects in a list of invalid areas, and then you only redraw these invalid areas. You know, the moved window is just memcopied. The pixels are just memcopied, and the area that we have uncovered is invalidated, and then in this loop at the end of the kernel or later in a task, In an idle task, you would just look, do I have invalid regions? If so, then I say, I want to draw this, I want to redraw this region. Okay? And when you do it like this, it's probably also a better idea not to draw from the back to the front. You know, drawing the desktop, then the window that's there, and so on. It's a better idea to draw from the front to the back, but that's really a lot of geometry and rectangle intersections and whatever. So that's really a lot of math behind that. But I think drawing from front to back is a lot of math. But I think if you move the window like this and invalidate the screen, and if you redraw the screen only by drawing from back to front, and all the widgets react to, so the draw method would also need a rectangle object, and the widgets would just say, okay, if I don't have any intersection with this rectangle, I just don't have to draw anything. I can return immediately, and otherwise I will draw into this rectangle the part that belongs to me. So then you can draw from the back to the front, and this should give you not a great performance, but a better performance than this flickering garbage that we have right now. But so this is really all I wanted to do for the graphics mode. One last thing I want to mention. You probably want to be able to draw, to render text, to write something on the screen. And in the last video, I've showed you this this file with the graphics modes. No, it wasn't the last video. It was the video 12. In this file, and I really have to say this, Chris Giese, big thanks to him. That's really a great file, and it's great that it's public domain. So we are not violating any copyrights or anything if we do this. So big thanks to him. So down here, you will find this bitmap font, 8x8. So here you, this is a bitmap font with 8x8 pixel characters, and so when you want to draw an A is, what is it, 54? You just go to the 54th row in there, so 8 times 54. Is the byte there is the last line of this bitmap font. So the byte at this index in this array, the bits of this byte are just the pixels down here, and then the next one is the pixels in the next line. At first, I thought that this would be the first line, and then this would be the second line, and so on. But then I had the characters mirrored. So it's from bottom to top. So this really should give you everything that you need to write your own desktop and windows and buttons and text box and so on. Your text box can get key strikes. You can have the mouse events and the mouse clicking and moving and all the good stuff. So So yes, this is all for the graphics mode. I hope this helps you a lot. As I've said, even just going into graphics mode, you just don't find any good tutorials on the internet except this one that I've shown you. It's the only correct one that I found, and I remember when I went to the VGA programming for the first time, I was really about to quit when I found this one good tutorial. So yeah, there you have it. Have fun with this, and tune in next time. I think next time will be also very awesome, because next time we will be doing multitasking. Yeah, next time we will look into how to have multiple things run in parallel. But for the sake of that, I will basically just uncomment everything that we did now. So the desktop and the VGA and the drawing and everything, I will put this in an area that I protect with a preprocessor directive, like this. But this I'm commenting out. And so on. Okay, so then you can just enable the graphics mode by uncommenting the define in the beginning and disable it for this, because the stuff that we are doing next isn't very graphical. So we'll be dealing with bytes again, and I think that that really requires you to be working in text mode again. So that's why I'm doing this now. Okay, so see you next time. Don't forget to subscribe so that you don't miss the next awesome video on multitasking. Hit like if you liked the video, and see you next time.